Okay, sorry about the break in the video. So the next part, D, state the coordinates of any relative minimums of f. So relative minimums, we would think minimums might be the smallest point, but the issue is that these are endpoints. And because they're endpoints, we cannot have relative mins. A relative min has to have like a dip in the function. It has to like go down and then back up, kind of like that. So therefore there is no relative min. For the coordinates of a relative maximum is the highest point on the graph within an interval, and since this is the highest point, the coordinates are at 2 on the x value and 5 on the y value. And for a piecewise defined function, one of them is a linear function, and that's a linear function between -4 and 0. So I'm going to say f of x equals, my slope is up 1, 2, right 1, 2, 3, 4. So if my slope is 2 over 4, that reduces to 1/2. So it's going to be 1/2 x. And then my plus b comes from my y-intercept, which is 4. So I put plus 4. And that's for x values between -4 and 0. Underneath it, we have the quadratic function. This quadratic function, the vertex is shifted right 2 and up 5. So if it's shifted right 2, it's going to be x minus 2 squared and up 5. But now we have to talk about our a value and how we find our a value. Our a value we can always find by going left or right one space and going down until we reach our graph. Okay, a typical mistake people make is they go left 1, down 2, oh, therefore it's got to be negative 2. It doesn't work like that. It needs to be left 1 x value, so left 1, and this likes it to be down 1/2, maybe even 1/4. We should probably do this algebraically. And here's how you would do it algebraically. Okay. So the function's y equals a parentheses x minus 2 squared plus 5. And I want to solve for a. So I'm going to take an x value for my graph. I'm going to take 0, 4 because that's still part of my parabola. So I'm going to use 0, 4. 0 is my x value, 4 is my y value. So 4 equals a parentheses 0 minus 2 squared plus 5. Or 4 equals 0 minus 2 is -2. -2 squared is 4. So it's going to be 4a plus 5. We subtract 5 on both sides. We get -1 equals 4 times a. And then we could divide both sides by 4 to get a equals -1/4. So my a value would be -1/4. And that is from the interval of 2 to, from 0, because that's the start of our quadratic function, all the way to 6. So from 0, x to 6. You can tell it should be from 0 to 6 because the last function ended off at 0, so the next function should start off at 0 unless there was like a gap between our functions. Like if there was no graph right here between these two, then they would be separate. Okay, but starts at 0 and goes to 6. Number 2, state the open intervals on which f of x is increasing. So it's increasing from 2 to 3. So from 2 to 3. It's increasing from 3 to 5. So actually I could combine these together to be 2 to 5. Because it's increasing, still increasing, so from 2 to 5. It's decreasing on 2 intervals. One of them is from 1 to 2, so I put 1 to 2. because that's from here to here. But it is also decreasing from 5 to 9. So I put union 5 to 9. Domain and range. Domain is all possible x values. The leftmost x value is -4. It's right here. The rightmost x value is +9. The range, the lowest y value is right here on your graph, and that is at 0. And then the tallest point on our graph is right here. It's not at 5 because 5 is the x value. You need to go to the y value. And that y value is up there at +3. Okay, for relative minimum, minimum would be a lowest point on our graph, so it goes down and then up. Right here is our dip, so that would be at 2, 0. Then we have relative maximum, and a relative maximum would be from, goes up and then down, so it changes slope here at 5, 3. And write a 3-piece piecewise function for this. So we have a linear function, so f of x equals, the first one's a linear function, and it's a straight horizontal line at y equals 2, so you put 2, and that's between the x values -4 and 1. So you write x is -4 less than or equal to x less than or equal to 1. The next graph, we have our parabola. Our parabola is shifted right 2 spaces, so we would put x -2 in parentheses, because the horizontal shift is always opposite. If it's right 2, we put -2. And for my a value, we could do it algebraically like we did in the first one, but this has a nice little shortcut because we go right 1 up 2 spaces. Our a value is 2. And it's not shifted up and down, so I don't need a plus k. And it's quadratic from 1 to 3, so I put 1 less than or equal to x less than or equal to 3. And then our last function is the absolute value function. The absolute value function is shifted right 5 and up 3, so we put x -5 up 3. I still need to put my slope. So my slope is rise over run. We go from the vertex and go to the right, down 2, right 1, 2, 3, 4. So if it's down 2 over 4, that reduces to -1/2. And that's between the x values 3 and 9. Okay, next, graph them on the same set of axes, where f of x equals g of x. Typo, there is no g of x. Let's just pretend, for example, that g of x equals, let's go with, I don't know, 3. Okay. So f of x says go left 1, there's our starting point, and we go up 3 over 1, up 3 over 1, and because it's absolute value, we're going to go up 3 over 1 in the other direction as well, because it should make a V-shaped graph. And g of x equals 3, that'd be at 1, 2, 3, that would be this graph here. So here's f of x, here's g of x. So because these two graphs cross at this point and this point, that means they cross at x equals -2. -2 is our x value where they cross, and we have 0 is our x value where they cross. So -2 and 0. We can verify this algebraically by setting these two functions equal to each other. So 3 absolute value of x plus 1 equals 3. Okay. This says 3 times the absolute value. I want to get the absolute value by itself, so I divide both sides by 3. And we get x plus 1 absolute value is equal to 1. And this turns into two functions because of the absolute value sign. This could either be x plus 1 equals positive 1, or this could say x plus 1 equals negative 1. So I subtract 1 from both sides, I get x equals 0. Subtract 1 from both sides, I get x equals negative 2. So there we have the solutions graphically and algebraically. Number 4. Solve the following absolute value equations for x and graph the solutions on the number line. So let's solve it. F of x is the absolute value and g of x equals this. And we want to have this function f of g of x. So this means start off by writing f of x, and that's this function here. But wherever we see an x, we are going to replace it with the g of x function. So I write the absolute value. I can't write x. I would write this whole thing instead, 3x plus 2. So that's f of g of x, and then plus 1 equals 12. Okay. So to solve it, I'll subtract 1 from both sides. I get 3x plus 2 equals 11. Absolute value. And this turns into two functions. You have 3x plus 2 equals positive 11. 3x plus 2 equals negative 11. So subtract 2 from both sides. I get 3x equals 9. And divide both sides by 3 to get x equals 3. And we also get, subtract 2 from both sides, 3x equals negative 13. And divide both sides by 3 to get x equals negative 13 over 3. So to graph the solution on the number line, we just make a number line. There's 0. 3 would be over here. And we put 1 point because it says equals. And at negative 13 over 3, we'd put it over here. And 1 point because it says equals. For number 5, we have to get the absolute values by itself first. That's a negative. Can't have negative in front. It has to just be absolute value. So we divide both sides by negative 1, and we get the absolute value of x over 2 minus 5 equals negative 4. There is no solution to this problem because an absolute value sign can never come out negative. So you would just write no solution, and I'm not going to write it, but you would say absolute value can never be a negative number. For 6, g of f of x, it's the same thing as writing this thing up here, except the f and g are backwards in this situation. So that means wherever we see x in g of x, we have to replace it with this guy. So this would be 2/5 absolute value. Instead of x, I have to write the function that's f of x equals to 20. Okay. The 2/5 is right here, and then g of f of x is right here. So 2 over 5, the way I could get rid, the way I get rid of a fraction is I flip and multiply. I flip the fraction and multiply it to both sides. So I get the absolute value of 3x plus 2 equals 20 times 5 is 100. 100 divided by 2 is 50. And this splits up into two problems. 3x plus 2 equals 50, and 3x plus 2 equals negative 50. Subtract 2 from both sides. 3x equals 48. Subtract 2 from both sides. 3x equals negative 52. So I have two solutions. I have x equals 16, because I divide both sides by 3. And dividing both sides by 3, I have x equals negative 52 over 3. So on a number line, over here at positive 16, I'd have a point. At negative 52 over 3, I'd have another point. For number 7, first things first, get absolute value by itself, divide both sides by 3. And 0 divided by anything is just 0, so this is x divided by 4 minus 10 equals 0. And we don't need to split this up into two problems, because if we were, we'd get the x over 4 minus 10 equals positive 0, and x over 4 minus 10 equals negative 0. But positive 0 and negative 0 are the same thing, so you would just get one equation of x over 4 minus 10 equals 0. Add 10 to both sides. X over 4 equals 10. And multiply both sides by 4 to get rid of the fraction, and x equals 40. And on a number line, 0, 40, just put a dot. Okay. For number 8, solve the absolute value inequality. So here we go. Again, you split them up into two problems. After absolute values are all by themselves. Absolute values are by themselves, so we're good to go. 3x minus 10 is less than or equal to 2, and 3x minus 10 is greater than or equal to negative 2. When you make the number negative, you have to switch the inequality signs. So we're going to add 10 to both sides, and we get 3x is less than or equal to 12. Divide both sides by 3, and x is less than or equal to 4. Add 10 to both sides. We get 3x is greater than or equal to 8. Divide both sides by 3. X is greater than or equal to 8/3. So on a number line, if here's 0, here's 8/3, and here's 4, 8/3 is less than 4. This says it has to be less than or equal to 4, greater than or equal to 8/3. So that means they're moving in the same direction. They're moving towards each other. So this answer would be a compound inequality. So this would be an AND statement. And you could write this as 8/3 less than or equal to x less than or equal to 4. X is between these two numbers. If you pick a number that's outside of this interval, such as 0, and plug it in, this would not work. For this one over here, we want to get rid of the fraction. To get rid of a fraction, you flip and multiply, and that's negative, so we're going to multiply by negative 3 over 2 times negative 3 over 2. So we get absolute value of x plus 4 is less than 6 times negative 3 is negative 18. Negative 18 divided by 2 is negative 9. And here's a little situation. We have the absolute value of a number is less than something negative. But we know that absolute value must always be a positive number, so therefore this will never be less than negative 9. So this would be no solution. And you would not have to graph it. Okay. Over here, subtract 4 from both sides, and we get 3 times the absolute value of 2/3 x minus 1 is less than negative 6. Divide both sides by 3, and we get the absolute value of 2/3 x minus 1 is less than negative 2. Same situation, absolute value will never be negative, so this would be no solution. For number 11, for this part over here, subtract 2 from both sides, and we get 2 times the absolute value of x minus 5 is greater than or equal to negative 2. Okay. I know my students, some of you guys might try to say, oh, there's a negative over there, no solution. Okay, don't make that mistake. You would divide both sides by 2, and you get the absolute value of x minus 5 is greater than or equal to negative 1. There's a difference between these two problems. This one says less than a negative number. This one says greater than or equal to a negative number. An absolute value sign can only be positive, so therefore it will always be bigger than negative 1. So this one would be all real numbers. For number 12, list all the points for g of x equals 0. So what this means, g of x equals 0, is where it crosses the x-axis, because that's where y equals 0. So just follow g of x, okay? And it said labeled points. So we're going to look for the labeled points. G of x is not labeled right here, but this would be a solution. Keep going up, down. This one's not labeled, but this would be a solution. Down and back up. Right here at point D. This one is a labeled point, so I would say it's D. Okay. But if I were to add some points, maybe I call this one K, and I call this one over here L. I could also add K and L additionally, if those were there. List all the labeled points for g of x equals f of x. This means where they intersect. And so they intersect, follow g of x, they intersect here at B. Keep going, they intersect right here at a point that's not labeled, but we'll keep going. And right here at point E. List all the labeled points that are solutions for x equals 0 on f of x. Where x equals 0, that means where it crosses the y-axis. Because if x equals 1 here and x equals negative 1 here, that forces x to be 0 here. So we go up until we get the f of x point. That is right there at B. So this would be the letter B. List all the labeled point solutions for g of x less than f of x. This means g of x has to be below f of x. So g of x is below f of x here, below, at B they're equal. Now g of x is greater than f of x here, but now it goes back to being below f of x. That's at point C. Keep going. At point D, g of x is still below the f of x line. At E, they are equal, and at F, g of x is above f of x, so it's just C and D. Okay. And same thing for this one, except it says greater than, so that means where it is above f of x. So g of x is below, equal to, now it's above, equal to, it's below, equal to, above at point F. For A, on the number line below, shade the intervals between the integers where the solutions to f of x equal g of x must exist. Okay. So if we look at this, f of x is above g of x. Okay. So f of x is above g of x. It's greater than. But then when we come over here, g of x is above f of x. So between 0 and 1, they had to cross somewhere. They don't cross at 0. They're not equal at 0. They're not equal at 1. So I would put open circles at 0 and 1. And connect them. Okay. Looking back at this, f of x is now the bigger one again. So they switched between 1 and 2. They had to cross somewhere. So between 1 and 2, not at 2. At 2, they're not equal to each other, so you have to put open circles at those points. And at the last point, f of x is still above g of x, so we don't have to worry about any more shading. That's our answer. On the solution number line below, shade where g of x equals 0. So whenever you go from positive to negative or negative to positive, you hit 0. So g of x equals 0. From negative to positive, it changes. So therefore, it has to be between 0 and 1. And then from 1 to 2, it's still positive. But from x equals 2 to 3, it goes from positive to negative, which means it has to cross 0. It's not equal to 0 at any of these points, so that's why I have open circles and shade between them, because it happens somewhere in that interval. Shade the intervals where f of x equals 3 must exist. So from 0 to 2, that's below 3. But from 2 to 4, you have to cross 3 in between those numbers. So between 1 and 2. And between 2 and 3, it's between 4 and 5. Those are both above 3, so there's no guarantee that we cross 3. So we just leave it. Okay, absolute value inequalities. Y is less than or equal to 4. So first off, I know that that's going to be a solid line because it has the or equal to part. So I go to 1, 2, 3, 4 on the y-axis and draw a solid line. And it says less than. If you are less than somebody, you are below them. So therefore, we are going to shade below the line. So I'm going to shade real nice and lightly because I want to see where they intersect each other. Now this says y is greater than x. This one is going to be a dotted line because there is no or equal to sign. And this is a linear function, which means you start at 0, 0. And it has a slope of 1 over 1. So I just go up 1 over 1, up 1 over 1, so on and so forth. And that gives me a straight line. And be careful, because I do this all the time too. Make sure it is a dotted line that you are drawing on your graph. It says greater than the dotted line. So if you're greater than someone, you are above them. So I'm going to start at this point, go above the point, and really shade in everything that's already been shaded before. So everything that's in this dark region is a solution to these inequalities. For 15, plus 1. So I'm going to go to positive 1 on the y-axis right here, and this is a dotted line because that does not say or equal to. And x squared follows that 1, 3, 5 pattern. So I go right 1, up 1, right 1, up 1, 2, 3. If there was more room on the graph, I would go right 1, up 5. Okay. It should not be increasing in the same steps because then it would not be quadratic. It would be linear. So a dotted line through all these. And it says greater than, so I'm going to pick any point on this function, shade above it, which means it'll be in this region, somewhere in this region. So for my other function, this says, if I were to reorder this, this would be y is less than negative x squared plus 1. So I would start at positive 1, and then I would go down 1 over 1, down 3 over 1, down 5 over 1, be off the graph. And it is a dotted line because it does not say or equal to. So I just put some dashes here. And it says below the function. So if I pick any point in this function, go below it, I would shade anywhere that's in here. There is no place where these graphs overlap. You might think they overlap at 1, but they don't, because this says strictly greater than, strictly less than. It does not say or equal to, so that point is not where they overlap. This is a no solution problem. There is no number that you could pick in any of these regions that would satisfy both of these equations. For 16, this says go left 2. Point out that it's a solid line. And up 1 over 3, up 1 over 3, up 1 over 3, up 1 over 3. And this is absolute value, so it's V-shaped. So be careful. Solid line. I freaked out a little bit there. I thought I messed up. It's in pen. And this says less than, so I'm going to shade everything that is below this line. Pick any point. If you're don't understand where to go, just put your pen on the line, and if it says less than, go down. It's everywhere down here. This other one says greater than the negative absolute value of x. So I start at 0, 0 because there's no shift. Again, a solid line because it says or equal to. And it's down 1 over 1. Okay, so here we go. And it says greater than, which means above. So I'm going to start at this point, and everywhere above it, I'm going to shade really dark where there's already been shading. And even right in there, just real close right in there. And even on the other side. On this graph, it said above, so above. Okay. Anywhere in this dark region is a solution. Okay. This is an exponential function. So for exponential functions, this has been killing you guys, so go ahead and do a XYT chart right here. And we'll use 0, 1, and 2. So 2 to the 0 power minus 2 is going to be 1 minus 2, which is negative 1. Our asymptote's at negative 2, so we're going to draw a dashed line through negative 2, like that. 2 to the first power minus 2, that's 2 minus 2, which is 0. So 0, negative 1, 2 comma 0. And then 2 to the second power minus 2, which is 4 minus 2 for positive 2. And since this does not say or equal to, make sure it is a dashed line. I almost messed up. And since this says above, we're going to shade everything above it, everything that's greater than this graph. The next graph says start at positive 1. So I start at positive 1. And this is a slope of negative 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. Okay, go ahead and make my graph. Again, it should be a dotted line because it does not say or equal to. And this says less than, so we're going to pick a point on the graph and shade less than, but only where we've shaded before. Our solutions are in that region. 18. This is in vertex form, so we're going to solve it using PEMDAS backwards. Opposite of plus 15 is minus 15 on both sides. 3 parentheses x minus 2 squared equals 75. After that is divide both sides by 3. So x minus 2 squared equals 15. Square root both sides. And this one gives you the absolute value of x minus 2 equals the square root of 15. So you get x minus 2 is the positive square root of 15. And when you add 2 to both sides, x equals 2 plus root 15. You also get x minus 2 is equal to negative root 15. So you add 2 to both sides, and you get x equals 2 minus root 15. Those are your two answers. Okay, for this problem, negative 2 times f of g of x plus 30. So negative 2, and because this says f first, that means I'm going to replace x here with everything that's in the g spot. So we do negative 2. Instead of x, I'm going to put x plus 3 in parentheses. Whenever you plug in for something, put parentheses around it. Squared. And then here's the rest of it. Plus 30 equals negative 212. Subtract 30 from both sides. I get negative 2 times x plus 3 squared equals negative 242. Divide both sides by negative 2. The absolute value of x plus 3 squared equals 121. Square root both sides. I get x plus 3 equals positive 11, and x plus 3 equals negative 11. Subtract 3 from both sides. I get x equals 8 or negative 14. For number 20, add 6 to both sides. 2 parentheses x minus 5 squared equals 126. Divide both sides by 2. X minus 5 squared equals, that would be 63. Square root both sides. And 63 can be broken up. 63 is the product of 7 and 9. 3 and 3. So we get x minus 5 equals positive 3 root 7. And when you add 5 to both sides, x equals 5 plus 3 root 7. And you also get x minus 5 equals negative 3 root 7. So add 5 to both sides, and you get 5 minus 3 root 7. We want to get everything on the same side. I personally like moving 3x squared to be positive, so I'm going to add 3x squared to both sides. Add 3x squared. So I get 3x squared plus 14x equals 24. And we still have to make it equal to 0. So we're going to subtract 24 from both sides. We get 3x squared plus 14x minus 24 equals 0. Okay. Try to factor this if we can. So let's see, I gotta do some guess and check going on. Don't want to mess it up on my paper, so I'm going to do this. So I know it's going to be x and 3x. They have to multiply to be 24, but add to 14 with opposite signs. So let's see, 2 and 12 maybe? 24 is either 1 times 24, 2 times 12, or 3 times 8, or 4 times 6. So I gotta plug numbers in and check. I'm gonna try 4 and 6. I know 4 has to go with the 3, because if 6 is with the 3, 6 and 3 have a greatest common factor, and that won't work out. So 4 and 6. Now I need to check to make sure they add to 14. 6 times 3x is 18x. X times 4 is 4x. And those would add to 14 if this was a negative 4. So that means I'm going to make this a negative 4 and a positive 6. There's my factor. Okay, I got lucky. I got it right on my first try. If I were to try something else, like 3 and 8, I know 3 can't go with the 3x because they have a common factor, so 3 over here, 8 over here. 3 times 3x is 9x. X times 8 is 8x. There's no way that these two would combine to be 14x, so I know I could scrap that one. So this would factor into x plus 6 comma 3x minus 4 equals 0. And I'm going to solve each of these. So x plus 6 equals 0 and 3x minus 4 equals 0. I get x equals negative 6. Add 4 to both sides. 3x equals 4. Divide both sides. X equals 4/3. Those are my two answers for number 21. For 22, I think I should do 22 on a post-it note because it looks kind of messy. So I want to get x squared. I don't know why I like having positive x squared. It's just really nice for me. So I got x squared plus 26x plus 36 equals 6x. I'm going to subtract 6x from both sides. I get x squared plus 20x plus 36 equals 0. And again, I'm back to factoring. Do any of them work though? I'm doing them in my head real quick. I don't think any of them will work. Actually, one of them might work. 36. The factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Because our a value is a 1, this works out pretty nice. Because if I look through my list, these factors right here can combine to be 20x. So this is x plus 2 equals 0, and x plus 18 equals 0. X equals negative 2. X equals negative 18. If you're not sure how to solve this problem, you can always use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this will give you a solution even if it's not factorable. I'm pretty sure we'll have to use it soon. Number 23. Okay. F minus g of x. So f minus g. So that means I have to put 8x minus 4 minus 7x squared equals 0. And I would like to put this in standard form first. So remember, x squared always goes first. This would be negative 7x squared plus 8x minus 4 equals 0. Can this be factored? I'm going to try to factor it. Let's see if we have some good factors. I know this would be 7x. One of them's a negative 7. The other one would be a positive x. These might even switch. I'm not sure which one's negative yet. The 4 would be 1 and 4 or 2 and 2. 1 and 4, 2 and 2. I don't know. I don't know. We got to see. 4, 1. I don't think it's factorable. Time to use the quadratic formula. X equals, b is 8. Our a is always in front of x squared. Our b is in front of x, and c is all by itself. So it's negative b, negative 8, plus or minus the square root of b squared, so 8 squared, minus 4 times a, which is negative 7, times c, which is negative 4, all over 2 times negative 7. Okay. Cleaning this up, I get negative 8 plus or minus the square root. 8 squared is 64. Negative 4 times negative 7 would be a positive 28. 28 times negative 4 would be negative 112. Let me double check that. I'm trying to do it quickly in my head. I'm getting hungry. Correct. And this is all over negative 14. I'm going to finish this problem on my post-it note. So, negative 8 plus or minus the square root. When you subtract those, you get negative 48 all over negative 14. And 48 can be broken down. 48 could be let's go with 16 and 3, 4 and 4. So it would be 4 root 3. So negative 8 plus or minus the square root, or 4 first, because 4 is outside the root. And because this is a negative under the root, that means we have to pull I out. I is the imaginary number. Square root of 3 all over negative 14. So when we solve this all out, we get, actually we can reduce this all. If you reduce it, negative 8, the greatest common factor of 8, 4, and 14 is 2. So this would be negative 4, 8 divided by 2 is 4, plus or minus 2i root 3 all over negative 7. I just divided each of these numbers by 2 because 2 is the greatest common factor of them all. And that would be my final answer. Use the graph below to answer the following questions. So, first one, f of 5 is greater than 1. So we go to 5. This is actually less than 1. 1 is up here, so this would be false. F of 8 is less than negative 1. Zoom out here. So I go to 8. Here's 8 right here. My graph is at negative 1 point something. That is less than negative 1, so that is true. F of x equals 1 between 5 and 6. So between 5 and 6, it's less than 1 here, less than 1 here, so this is false. Between 0 and 2, it has to equal 1. Between 0 and 2, it crosses 1 right here, Therefore, this is true. F of 0 is 0. At x equals 0, our y value is 0, so that is true. F of negative 7 is at 1, 2, 3, 4. So this is also true. F of 3.743. So 3.743 would be somewhere right here. But look between 3 and 4. Between 3 and 4, it never actually crosses 1. So there's no way it could equal 1. That's false. At 9.32, let's just go to 9. 9 is right here. Between 9 and 10, our graph is at negative 2. It's actually negative 2 the entire time between 9 and 10, including 9.3. True. Has a relative maximum at negative 2, negative 4. At negative 2, negative 4, that's called a relative minimum. So this is false. Relative maximum at 3, 2. At 3, 2, the graph went from increasing to decreasing. That is true. Relative minimum at 9, negative 2. At 9, negative 2, you cannot call this a relative minimum because it doesn't go from decreasing to increasing. It goes decreasing to constant. So therefore, this would be false. And the last one, a relative minimum at negative 2, negative 4. Negative 2, negative 4. It goes decreasing to increasing. That is true. Study hard. See you Monday. Good luck. Have a great weekend. Stay out of trouble. Don't get arrested. Love you guys.